Our third presenter, but fourth presentation, is from Martin Strohmeier. In case you missed the last talk, Martin is senior scientist at the Swiss Cyber Defense Campus in Zurich and a visiting fellow at Kellogg College. He will be speaking about how armasusisse science and technology has been conducting open security research with real avionics hardware by working closely with industry and regulators. So please welcome to the stage again, Martin Strohmeier.
Yes, some people are still here, excellent. Welcome to my little soapbox corner. As the intro said, we don't do only privacy, we do a lot of security stuff, and I'm trying to talk a little bit about our approach, about how to do this and how to do research in aviation security. First, let me briefly try to convince you that we actually do something useful in aviation research. As mentioned, we do research with universities, we have stakeholders in the government and the military, where we're based ourselves, and we work with industry, mostly for knowledge exchange and disclosure of things we find. We've published over 60 papers in the area over the past 10 years, with 50 co-authors from more than 20 institutions, so that's a very broad research activity that we're doing. Currently we have over 10 students working on various topics. Most of them are from ETH Zurich, EPF and Lausanne, but also some other collaborations across Europe and actually also in the US. So we have a lot of exciting results coming up that may be in the village next year, or if you follow what we're doing, you might see it at some other security conferences. So stay tuned. Caveat, this is obviously quite a long-term government effort, so it's not something that's trivially recreated, but I hope that some of the lessons that we have are still applying to you or what you're interested in, so I hope you get some value from this. Something that illustrates more technically what we've done over the past 10 years, something that we built originally just to illustrate how many different types of aircraft communication and wireless communications are going on over different flight phases in aerospace. And the green numbers tell you when we published some research on these specific, all these specific communication technologies. Some stuff is not on here, so the privacy research that I've shown before, or around proximity warning system, or when we do research on human factors, it's not captured by this, but broadly all the technologies are on here. So let's on trust, but let's start with trust first. These are some headlines from following some Black Hat and DEF CON talks around the time when I got into this topic, right? So that's what you sometimes get when you say, oh, I can hack this specific part, and it gets into the media, and then suddenly planes are falling out of the sky, right? The problem is the FAA, lots of people in the aviation industry, they either know this is not true, or they believe it's not true, or they definitely disagree, and they definitely disagree with having these headlines. Going from there is very difficult to work with them, so we typically try to avoid having any of these headlines that claim, oh, well, we can hack aircraft, we can hack ground stations, and they will fall out of the sky. That's not ideal. On the other hand, also not ideal, and not building trust within the security community is if you say, there's nothing to see here, right? We are safe, there's redundancy, even though all of the redundant systems are also hackable, or vulnerable at least. And you answer also over the media and say, hey, there are no vulnerabilities in any of these systems, so nothing to see here, don't do any research. Also not building trust. What we've been trying to do is basically 4 steps. So we're trying a more academic approach. We really, our research takes time for sure. We try in a very academic, scientific manner with students, universities try to avoid the sensationalism, the headline-grabbing approaches, right? Of course, when we find something, we work with industry, we disclose responsibly. We try to thoroughly evaluate. Not if you find some issue and they say, oh, here, planes are falling out of the sky. No, the important thing is that you don't just look at one system. If you've seen 10, 15 different communication systems alone, right? That's not even talking about all the other systems on the aircraft on the ground. You need to look at them all at once, basically, and say, okay, what sort of impact can you really have on pilots, on the ground, or on the system overall? So generally, all of our research has concluded that, no one's falling out of the sky, right? But in very specific circumstances, there can absolutely be relevant problems. We come from IT security, academic security background, so we had to go to aviation, right? You have to make yourself visible, you have to start talking to ANSPs, to airlines, to regulators, to everyone really working in aviation in this space, also to manufacturers, and try to find individuals, try to find pilots, try to find air traffic controllers who can really help you understand how they see their systems, right? And then you can basically bounce back and forth. What are these security issues that we've seen, and what sort of impact would they have on your work? If you do that, then it's much easier to establish some credibility as the aviation community. And finally, this should actually read evaluation, not simulation. You need to convince people that the attacks and things that you're researching and the vulnerabilities that you're finding, that they're real, right? So if you look at some standards and there's no security built in, then that's a problem. But what sort of problem is it? Then you can start simulating attacks and you can get closer to the truth. But still, at the end of the day, we've always heard, well, this is not the real thing. You're not looking at the real system. This is just software-defined radios that you're looking at, and this is not an effective evaluation. We don't believe you. And that's the second part of this talk, how to get around this. Of course, doing all these 4 steps is hard, right? It's definitely easier at the government, in my experience. So when I was at university before, if you go to regulators, if you go to manufacturers, doing the same work basically, but the response rate was much, much lower. So aviation manufacturers, they typically wouldn't reply if you have some issues. Things change slowly, but in my experience, if you're independent or at the university, much more difficult than if you work at the government or the military, where you typically get some good answers and people may be hesitant, but they probably want to work with you. It takes time. I think I made that point. We've been working this over 10 years, and by now, we're really only where we want to be with real-world evaluations. Personal connections, I've mentioned this. Go find people at important institutions, talk to them, because very often this doesn't work on the high-level policy level, right? You need to really find some champion in different institutions and work with them on what you think is important and interesting. Defense, we are in the defense space, and a lot of aviation stuff is, of course, run by manufacturers and institutions that are also in the defense space. So even if you don't like it, it's probably necessary to get an in there somewhere. Collaborate as widely as possible is certainly an important point. So don't stay, just in your bubble here, even though the Aerospace Village is excellent initiative where you can meet a lot of people. But go out and find everyone who wants to work in the space. And also go not only to IT conferences, do go to aviation conferences, tell them about security issues. They still don't know, they still don't understand. So there are several big aviation conferences, and yeah, you should go there and tell these people. It helps a lot. I have a couple of disclosure examples as well that we've had over the past few years. This was a positive one. We were just collecting some data back then and saying, oh, okay, here, there's ACARS, it's a data link if you're not familiar. And several airlines are just sending credit card data over this data link in the clear, right? Everyone can just collect it. Some websites on the internet collected it. Somebody needed to tell these airlines basically, well, stop doing this. So we reported this to a few people, and it took a few years, to be honest. These processes are very, very slow. But they were eventually fixed, so we take that. We have some negative examples, however, as well in this area. For example, we had a paper a few years where other people too, noticed that these data links, they have something that, well, manufacturers call encryption. However, it's not encryption, it's really just a monoalphabetic substitution cipher. So best case, we can call it obfuscation. So we wrote a paper, we talked to the manufacturer responsible for this sort of thing and said, do you really want to do this? Or do you have something better maybe? But yeah, well, we heard from them say, no, that's fine with us, honestly. And the arguments were like, well, it's not encryption, right? It's just obfuscation. And there's no sensitive data on these data links, right? That's why they have some sort of obfuscation, but they said, okay, there's no problem here. We also don't need, there are no industry standards on this, so we can do what we want. We don't need to do security because there's no industry standards telling us to do so. Finally, they said everyone using this sort of encryption on an aircraft, they know it's not encryption. So they said they're all basically experts on security, and they're fully aware that this is not encryption, it's just obfuscation. That's what we got from the lawyers. I guess that's the job of the lawyers. However, afterwards, we looked at the software that you use for this data link, and my eyes don't deceive me. It clearly says encrypt downlink. And if I'm not an expert, even if I am an expert, I think that uses some proper encryption to secure my data, right? If I have that option. And only if I really look at the data myself, I realize, oh, this is trivial and anyone can basically crack it. So yeah, good and bad examples both exist. That brings me to the second part of my talk, and that's labs. How do you really build aviation security labs so that you can, well, find real vulnerabilities in practice? Our original motivation around 3 years ago was, well, we wanted to do mostly radio frequency attacks, real ones. So it was a decade of research, right? Simulation, you find lots of papers, lots of talks at DEF CON and Black Hat, talking about things like ADSB, ACARS, multi-iteration, collision avoidance, and everyone says, oh, it's not encrypted, it's insecure, you can do whatever you want. However, yeah, aviation experts, but also academic reviewers told us, this cannot be done in a real aircraft or in a real ground station, on a real system. There will be redundancy, there will be some black magic that will prevent these attacks. Nobody tells you how, but they will say, no, this can't work. And even if you believe they're wrong, you need to show it. You need to go out and really, really show it. So basically, until then, we had this. We have avionics simulated with SDRs, as you can see on the right here. Some computer will simulate the software. You have software-defined radios receiving data, and you have the actual attack, also in software-defined radio. That part is okay. But the avionics part, yeah, you need to have real avionics here to show people that it's a problem. There have been some related efforts on this. There was some paper 4 or 5 years ago where they also built avionics lab. I wasn't looking at the radio frequency parts, but they were looking at things like Ring 429 and say, okay, we have a bus here, what can we do? So that was interesting. You can check it out. Of course, we've seen stuff in the village, right? Also in the media over the past few years. So these were great efforts. Maybe you've also seen this, where the Department of Homeland Security offered some people at least a way to look at a real aircraft, maybe not the newest one, but a real aircraft. However, that quietly ended around 3 years ago. So, and none of the results have ever been made public, to my knowledge. So, certainly commendable effort, very useful, but not for me at least directly. Several challenges, of course, when you try to build such a lab. It's a fairly novel thing, at least I'm not aware of anyone doing this publicly, so there's fairly uncharted ground. There are some projects that I know of. They are OEMs like Airbus or even the Swiss manufacturer Pilatus, but yeah, typically unless you're really working with them, there's no way you can access it, and also probably you're under NDA, right, and you can't do what you want. Some avionics manufacturers we have also seen they're not very open, definitely not when you're at the university, but even to us they were not very open in building such test beds for security. Second thing is, of course, you have trade-offs, right? Well, you can spend a lot of money, that's one thing. The more money you spend, the more realistic it gets, but complexity also grows, and then it gets obviously much harder to just look at the systems that you're interested in. Costs here, you're easily in the 6 figures quickly, so at some point you think, well, maybe you should just buy an aircraft, but again, there the complexity is a problem, because, yeah, working on aircraft it's much harder to attack systems and debug everything than if you build a lab just exactly for this purpose. So, high-level concept that we had is we wanted certifiable avionics hardware that definitely believes that it's deployed in a real aircraft and actually flying. We have all the radio frequency interfaces, so lots of antennas. We should be able to spoof, to send everything to these antennas over the air. So we can really do some testing, spoofing, jamming, fuzzy testing. And we also said, well, we start with something, but we want to have it extensible, right? So if this works well, in the future we want to have more technologies built in there. This is the concrete overview of our first attempt. We got some hardware from Garmin, GTM 750, GTX 3000 and GTS 8000. These are all connected and integrated by certified aviation integrators. They all have the right antennas, so we have antennas for the collision avoidance system, for the transponder, for the GNSS system, of course. And the only thing that we really need to simulate is the barometric altitude. So that's fed in by a PC because, well, there are ways, but it's a bit too complex to convince a system that it's maybe 10,000 feet up in the air and not standing on the ground if you don't do it with simulations. Safety is of course important. So, you know, we have several approaches. We have large Faraday cages where we can do radio frequency testing. And we have anechoic chambers available where we can put all this in and start sending freely without bothering anybody. That's how the first original lab looked assembled together. So we have a full rack with all the avionics. Computer feeds, again, barometric altitudes, and the antennas at the back. And then the system can be controlled basically with the same touchscreen as a pilot would. First thing we did was, let's try out some well-known attacks, right? Is there any protection against GPS spoofing in these systems? Turns out no, there's not. So this aircraft, even though it was the lab, even though it was in Switzerland, you can make it believe, oh, I'm in Scandinavia, or as you've seen in the video here, it's actually even flying. So we just spoof the GPS in a way that it thinks it's flying. That's all been done with software-defined radios, openly available software. Second thing we did is all these old attacks on, ADSB and also collision avoidance systems. Yeah, some of them work out of the box. You can go send some aircraft on collision course. You don't get the full resolution advisory. For that, you really need to attack the TICAS, which is something that we're working on at the moment. Then we started with some extensions. CPDLC, control the pilot data link communication system. That we wanted to look at this because this is really being rolled out, particularly in Europe and the US. Everyone going via the Atlantic, commercial aircraft, they now need to have this new system shortly. So we bought more hardware, this time from Universal Avionics. Had, as you've seen, have its own rack. Then we worked with our local ANSP and Eurocontrol to be able to connect to a rail ground station, be able to log in with these systems, and from there, of course, you can go capture the data. It's all unencrypted, it's also not authenticated. So you can really look into the protocol and try to figure out how do I really attack these systems best, or how difficult it is. Also work on this forthcoming. Second extension was that SATCOM system, Iridium, that was offered by the Garmin system, so you can go and simply send emails, SMS, or even call using the avionics hardware. Iridium, incidentally, is of course also unencrypted, so it's quite trivial to find your own calls and your own SMS on this system. Electronic flight bags are a big thing, you've also seen it in the village. So we also bought the extension that you can connect your phone, your iPad to the flight management computer using Bluetooth and Wi-Fi. Also, obviously, lots of security research opportunities here. And finally, we built a multi-iteration system recently in Switzerland that is very practical. If you're not familiar with multi-iteration, it's also being used a lot to back up ADSB and other insecure systems, or at least it's argued that this could work. So we said, okay, we also need to set up such a system and do security research on those. So most of this is really ongoing. The lab has already been used in person by lots of people in different from different countries, lots of our own students. I've teased all of these results on these supported technologies, but yeah, we're open for collaborations as well on this. If you say, hey, this is really cool, I would like to try it out, give us a shout. Because, yeah, we built this not just for us, but we said, okay, we really want to improve aviation security in the long run. Brings me to the end of my talk. 4 takeaways that I have. I think building this sort of trust that you can go and conduct aviation security research responsibly and have some impact. It's hard, but it's necessary and worth it. So yeah, don't just look at the system and find a flaw and then, well, basically leave it at that. Second one, simulations, software attacks, that's all great, but we need to take this leap eventually. So we really need to invest in better, more realistic systems to find out what sort of impact can these things really have. To that extent, we built the lab. It's certified hardware. It supports radio communication, which I personally think is really cool. That's what I typically work on. And I think it's important to do this to really overcome any of the doubters. And as I mentioned, it's there for research, it's for collaboration. So please contact us. Thank you.